Okay, in the previous videos, we looked at how to evaluate radicals, so things that we could take the square root of or cube root of. In this one, we're going to look at simplifying them, even if we can't take the square root or cube root completely. So, for example, if we have, let's say we've got square root of 45. Okay, I can't take the square root of 45. There's not any two things that I can multiply that match to get 45. But maybe I could break this up and simplify it. Okay, so this is the same as 9 times 5. Okay, 45 is the same as 9 times 5. And if I have a square root of multiplication, that's the same as multiplication of the square roots. Okay, that's the multiplication property for square roots. So these two things are the same, and now I can evaluate square root of 9, that's 3. Square root of 5, I can't get any more factors for that. So I'm fully simplified as 3 square root of 5. Okay, so what we're looking for is we're looking for these factors here that we can take out that we can take the square root of. Okay, let's try another one. Let's say we've got square root of 18. Okay, so the factors of 18 are, we could do 3 and 6, but that doesn't help us. I can't take the square root of either of those. 18 is also the same as 9 times 2. That would help me because I can take the square root of 9. So I'm going to break this up as 9 and 2 using our multiplication rule. The square root of 9 is 3, and I've got the square root of 2 left over. So I get 3 square root of 2. Okay, next let's try square root of 20. Okay, I can't take the square root of 20, but let's try some factors. I could do 2 times 10, but that doesn't help us. 4 times 5 would help us though, because I can take the square root of 4. So if I break this up as 4 times 5, I can take the square root of 4 and get 2 square root of 5. 5, I can't reduce anymore. Okay, let's try one more. Let's do square root of 32. Okay, so sometimes when you're going through these factors, you find a factor that will reduce, but you've got to make sure that you factor all the way. So when you see 32, maybe you think 4 times 8, and you say, okay, I can reduce 4. So we do 4 times 8. Square root of 4 I know is 2. But I need to look at this one. I can reduce 8 more. I can do more with 8. So I need to reduce again. Okay, so we can reduce 8 as well. We can make this 2 square root of 4 square root of 2. So this 2 is going to stay out front. And I'm breaking up 8 as 4 and 2. And again, square root of 4 is 2. So I get 2 times square root of 2. And I can put these numbers together as 4 square root of 2. Okay, so even if you reduce ones, you got to make sure that you reduce all of the way. So 32, I could have thought of another way. I could have thought of it as 16 times 2. And square root of 16 I can do, that's 4 square root of 2. So that would have got me there in one step using the square root of 16, but it's not often that we think of a factor that big. It's more likely that you would think of 4, and then remember that you've got to check and see if you can reduce any more. So either way, you should get down to 4 square root of 2. It's okay if you have to do it in a couple steps. Okay, now we looked at the square roots of variables as well. So we looked at like square root of x squared, and we said that square root takes half of the exponent, and we could do x to the 4th is equal to x squared, and so on. But what if it's not an even exponent? What if we have something like square root of x cubed? Well, I can't take the square root of x cubed, at least not to a whole number. But what I can do is I can break this up as well. So I'm going to break it up to something that I know, which is x squared. Okay, so x cubed, there's 3 of them, so I can break that up as 2 and 1. And then x squared I can take the square root of. Okay, I know that that's x, so I would get x square root of x. Okay, so for square roots, I want to break off an even exponent that I can take the square root of. So let's say that we've got x to the 7th. Okay, so what's the biggest even number I can do? I can do x to the 6th and 1x left over. I can take the square root of x to the 6th. Okay, that's going to take half of that. That's going to give me x cubed right here. And then I'm going to have square root of x left over. Okay, so just like with the numbers, break it up into pieces that you know, and you can reduce it that way. So let's say we've got like x to the, let's say we've got x to the 13th, do something big. Okay, so the biggest even number in that is x to the 12th and 1x left over. Okay, so x to the 12th, I know I can take half of that, I get x to the 6th, and I've got 1x left over on the inside. Okay, so if you have an even exponent, the square root can evaluate it. If you have an odd exponent, you're going to have 1x left over on the inside. Okay, so take the biggest even exponent you can, and then you're going to have 1x left over on the inside. Okay, so that's for square roots. Let's switch our mental mode here and do some cube roots. Okay, cube roots. So we looked at cube roots like cube root of 8, and we said that's 2 times 2 times 2. Okay, so now we need 3 matching factors. So it may help if you think of the perfect cubes. I think you're a little bit more familiar with the squares. So when you're looking at cube roots, okay, 1 cubed is 1, but a factor of 1 doesn't do us any good. 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. And we'll go ahead and throw 5 cubed up here. But these numbers are so big that it's hard to find them as factors. So a lot of times for these, you're looking for a factor of 8, maybe a factor of 27. If you can find a factor of 8, then you might be able to get a factor of 64. You can just do 8 twice. Okay, so let's look at an example. Let's say we've got cube root. Let's do cube root of 32. Okay, cube root of 32. So I need 3 matching factors. So I can't do anything with 32 directly, but I can reduce it. So 8 is a factor of 32. So I can break this up as 8 times 4. Cube root of 8, I know, is 2. So this is going to be 2 cube root of 4. And I can't do anything with cube root of 4 because I need 3 matching factors. It's not a square root, it's a cube root. Okay, so that's fully simplified. Let's say that we've got cube root of 54. Cube root of 54. 8 doesn't go into this, so check for 27. 27 does go into this. This is going to be the same as 27 times 2. Okay, cube root of 27 is going to be 3. 3 times 3 times 3 is 27, so we get 3 cube root of 2, and there's nothing I can do with cube root of 2. Okay, so cube roots are a little bit more limited because the numbers get really big really fast. So you're pretty much looking for these factors. All right, let's look at cube roots of variables. So remember we said that the cube root takes 1/3 of the exponent. Okay, so if you're talking about exponents, it takes 1/3. So we had to have things like cube root of x to the 3rd, cube root of x to the 6th, cube root of x to the 9th, and so on, to be able to take the cube root. So we can simplify, okay, the other numbers. If it's not a multiple of 3, we can still simplify. So let's say we've got cube root of x to the 4th. Okay, if the number on the inside is bigger, you know that you can simplify. So we've got more x's on the inside, so we should be able to simplify this. So I can think of x to the 4th as x to the cube times x. Okay, there's still 4 of them there. And I can break this up. Okay, and this cube root of x to the 3rd I know is just x. So I'm going to get x, and then I've still got this cube root of x. Okay, let's try one more of those. Let's say we've got cube root of x to the 10th. Okay, so I want to reduce this as far as I can. So I've got to think, okay, what's the biggest multiple of 3 that I can fit into 10? The biggest multiple of 3 would be 9. So I'm going to break this up as x to the 9th. And then I'm going to have 1 left over. Okay, I need to keep a total of 10. So the biggest multiple is 9. 9 and 1 makes 10. And then I know that I can take the cube root of x to the 9th because I can take 1/3. And I'm going to get x cubed. And then I've got cube root of x left over. So x cubed, cube root of x. Okay, so now we know how to take square roots and cube roots of numbers and variables. Let's go ahead and put that all together. Okay, so let's say that we've got 24x to the fifth. Okay, so we want to reduce 24x to the fifth. We know how to do numbers, we know how to do x's, so just split it up and look at them separately. Okay, so I'm going to think of this, you don't have to write out all these steps, but this is how I'm thinking of it. I need to reduce 24 and I need to reduce x to the fifth. So do what we just did for the previous steps for the numbers and for the variables. So we need factors of 24. Okay, so go through all the factors of 24 and find one that'll help. 4 and 6 should help. So I'm going to break up 24 as 4 and 6. Okay, we're back to square roots now, so I can take an even exponent for a square root. So I'm going to break this up as x to the fourth and x. Okay, and then go through and take square roots of everything that you can take the square root of. So square root of 4 is 2. I can't do anything with square root of 6. X to the fourth, I take half, I get x squared. And I can't do anything with square root of x. Okay, so we just go piece by piece like we did before. Now anything that's not in a square root comes out to the front together. Okay, so our 2x squared comes out to the front. Anything that is in a square root goes back together under the square root. So square root of 6 times square root of x would give us square root of 6x. I can't reduce 6, I can't reduce x, so I am done. Okay, so that's our final answer. All right, let's try another one. Let's say we've got square root of, let's do, trying to think of a number that we haven't done yet. Let's do 28 x to the 7th. Okay, so I want to break up the 28 and I want to break up the x to the 7th. So factors of 28, 4 and 7 will help us because we can take the square root of 4. So I'm going to break this up as 4 and 7. 4 times 7 is 28. X to the 7th is odd, so I'm going to break that up as x to the 6th and x. Okay, so the biggest even exponent I can do is x to the 6th. That's going to leave 1 left over. All right, now go through and take the square roots. So I can take the square root of 4 is 2. Can't do anything with square root of 7. Square root of x to the 6th, that's going to take half. And then I'm going to have square root of x left over. Okay, so any numbers come out to the front. 2x cubed is not in a square root. And I've got square root of 7x left over on the inside. Okay, so there's a couple of square roots. Let's try one cube root together. Let's say we've got cube root of 16x to the 8th. Okay, so now we got to think cube roots. Cube roots, we're looking for cubes. Okay, so what's a cube root that I can fit into 16? So remember, I'm looking for 8, 27, 64, 8, 64, 125. Okay, so 8 goes into this. So you say, okay, I can do the cube root of 8. 8 times 2 is 16, so I'm going to break that up as 8 and 2. All right, x to the 8th, I need a multiple of 3. So the biggest multiple of 3 that I can fit into 8 is 6. So I'm going to break this up as x to the 6th and x squared. Okay, so that gives me a total of x to the 8th. All right, now go through and take your cube roots. So cube root of 8 is 2. Cube root of 2 left over. Cube root of x to the 6th is x squared. Remember, we take 1/3. And cube root of x squared left over. Okay, so the numbers come out to the front, 2x squared, and then whatever's underneath the cube root can go back together, 2x squared. Okay, so 2x squared on the outside, and just as a coincidence, 2x squared on the inside. Okay, now look, this x squared you can't reduce because 2 is less than 3. That's how you know when you can stop. If the number underneath is bigger, like 8 is bigger than 3, you can reduce. 2 is less than 3, so we can't reduce anymore. We know to stop there. Okay, so that's the basic idea for simplifying.